Okay, so here we have Acer Monitor. It's apparently it's not working. Let's plug it in and see what happens. Right, so let's come in with the power supply. And here. So it's not very visible, but we have like the blinking light. Right, so first things first. Let's check the power supply if it has corresponding voltages, which we are a bit lucky. Let me show you quickly why. Right there, the voltages are numbered. It says 12. It shows 12, 12, ground, ground, 5, 5, 5, more ground, NF, and then dim. So let's plug this thing in and measure some voltages. Okay, so let's start with ground and 12 volts. Jumping. Alright. How about 5 volts? So the power supply switching on and off, which means we have shorted components somewhere. So let's see if we can detect anything under thermals. Alright, so let's power on and see if something gets hot. Oh, okay. We have an Armageddon here. Alright, let's power it down. This is this is an Armageddon. 200 C. At the moment I'm going to focus in this area and see what I can find. Right, so what's happening, as soon as we apply power, the resistor goes red hot. Okay, so this resistor goes crazy hot. So need to focus a bit more here, and we need to determine it's gonna be probably either this transistor have failed, or the resistor, or the capacitor. It's something here. So let's take a quick look and see what we can figure out. Looking from high above, this this black line tells me that this is a high voltage area. This capacitor can really zap you to the next dimension, I think. But here, past the transformer, we should go down to normal voltages, like over here. These capacitors are only rated at 35 volts. This one is 16 volt. So yeah, I think this area is like something like 12 volt, in the region of 12 volts. So it should be pretty safe to look at. And so we're gonna start with some basic resistance measurements on. So what can you tell me? What's your story? All right, what we have? 150 ohms. Funny, but that's, yeah, it has markings of 150 ohms, so that looks all right. Okay, so let's measure this guy. Just I don't know how to. I just don't know how to get close to it. Right, I think we're at the point where we have to take the board out. Okay, so this is interesting one. So basically, I'm just gonna try to figure this out the way it was. When I got this device, the power, even though it says 12 volts, it's a bit more, but hey, that's weird. But the power was rising really high. It was rising up to 24 volts and then falling down. It goes up and down. It's going. The resistor in here was getting really hot, and when I measured this component, that's like some kind of a suppression diode. It measured faulty. It was definitely faulty. So I went and bought the new ones. They only costed me £1, but I got like five of them. But when I replaced this component, the fault didn't disappear. But but after that, what happened was this capacitor, or this capacitor, now former capacitor, once I replaced this component, this capacitor starting heating up. And so then I measured it with, it's basically it is 10 volt 680 UF. And if I measure this capacitor with my let's see, I'll have this device here. I'll plug the capacitor there. I got the capacitor suspended. If I measure this capacitor, it will not measure. It's falling short of its original value. So so when I replaced this component, this capacitor started heating up. So I had no choice but to replace this capacitor with another one, and and when this capacitor got replaced, the heat disappeared, the resistor is no longer hot, and everything went normal. So I don't know I don't know what happened, but either this capacitor got over time dried out and the voltage became unstable, or this component failed and affected the capacitor, or whichever way, basically. But these two components got replaced, and now the monitor is working. So that's good news overall. I guess that's, we can call it a victory. All right.